Can you see my screen?
Yep, perfect.
All right. Do you see my slide, Chen?
Yep.
Okay. Thanks for everyone. Thanks for coming at tonight's event. Chen did a great presentation. My name is George Chen. Tonight's topic will be developing AI applications with open source models and tools. Oh, where is it? Um, Sorry. Before we get started, I want to introduce myself. As what I said, my name is George Chen. I'm a software engineer and an architect. In my last 15 years, I have been programming Java, C Sharp, Golang, JavaScript, and most recently Python. I'm a self-taught machine learning AI practitioner. Actually, I started with Andrew Ng's machine learning course on Coursera, and that's one of the most popular and famous course on Coursera, and that's where we started my journey. That was 2013, and then my most learning platform actually Coursera and Udacity. I finished multiple AI deep learning courses and deep learning specializations, and I also completed one of the Udacity deep learning nano degree. Um, my feeling over MOOC is they're quite effective and useful for your personal growth and your career development. Before I joining Cognitive Quanta, I was a software engineer, worked in multiple enterprise projects, and I was able to use the machine learning, and AI knowledge in my projects. And from September, I joined Cognitive Quanta as a full-time lead AI integration engineer. So that's enough for myself. Today, we are going to talk about several different concepts. Since we don't have much of time, I'm going to briefly introduce the concepts, and in the future, I'm planning to expand the content for each one of them and have some more in-depth discussion and presentation over it. So as a software engineer, our job is to deliver products to end users. But based on statistic, only 1 of 10 data science projects actually make to production. Even with those projects made to production, only 5% of them were actual machine learning model code. And most of the code are web service, user interface, and even infrastructure code. So we as software engineers, we are here to fill the gap between the final product to the AI machine learning research. Here's a chat I downloaded from Team Data Science Process website. This is a recommended data science project process. You're going to see we start from business understanding as compared to our conventional software development. This is the stage for user requirements collection and the business analysis. And then the requirements going to hand to machine learning engineers. They will collecting data, do the pre-process, they clean the data, labeling, and build a model to train, to validate the data and reach a final result, meet the matrix, the accuracy matrix, a performance matrix. And then the model going to be handled to infrastructure guys and the software developers to make a product to our customers, and the model going to be deployed to an inference server, and the web service user interface application is going to be developed to serve our end users need. That's a kind of a standard process flow. But unfortunately, it's very expensive. You see the modeling and data collecting. Not everybody can afford a team of PhDs, machine learning engineers, and even collecting data is time consuming and very expensive. If you are a hacker, you want to pull something, or you are just an entrepreneur, business owner, and you have an innovative idea, you want to make it into your own products, you probably can find some pre-trained open source available online model actually does your need and pretty much likely meet your expectation and can be compared to those commercialized products. Actually, today we're going to use an open source model developed by Samsung Research, the mobile phone manufacturer actually. They publish models and for some very interesting AI in-paint model, and we're going to use it to make an app. And the app going to compare to the latest Google Pixel phone. They have an app called Magic Eraser, and you compare to our demo app, which we put into 2 days. Actually, the result is kind of more than satisfying. Where you get those models? The first place, I suggest you to look at their Hugging Face. I think most of you probably, if you pay attention to machine learning and deep learning community, you must have already heard about Hugging Face. Hugging Face made the open source models. They have a platform to host the demo apps. If there's some kind of the most STOA, state-of-the-art models, you can find the implementation in Hugging Face. And if there's a new research result, a new paper published, you can expect the Hugging Face have them available on their repository really probably the last month or several months, hopefully. Another place is TensorFlow Hub and the PyTorch Hub. They're great source for finding models as well. And another place is NVIDIA graphic container. They offer some very good resources, and their Docker tools for NVIDIA GPUs is something very important for the developers working on with AI application, and also for the researchers as well. So for the user interface, there are several frameworks available as well. Streamlit, that's pretty much a go-to tool for the data science to make a web application to test their data, to test their model. Radio is a similar thing made by Hugging Face. But if you are really thinking about making a production level things, you can always use those popular front-end framework like Vue.js, React.js, and make your app yourself with some this kind of a commercial or uncommercial, the open source project, the front-end libraries. Inference server is where you host your models. Your model is a bunch of probably TensorFlow networks, PyTorch networks with checkpoint. You want to give the data and get a prediction result out of it. So the inference server provide either HTTP, REST API, or probably gRPC or other protocols, and you can expose your model to be consumed by other service. Their TensorFlow serving, their PyTorch server, and MLflow, Kubeflow, NVIDIA Triton, and Tensor RT. All these things, they have their pro and cons. But one thing is they all involve some learning and their learning curve behind it. So if you're kind of software engineer good at the backend, you can always write your own wrapper, either REST API or gRPC over the model by yourself. And this is the approach our demo going to be using. Before you start your project, you're going to ask yourself what kind of app and the nature of the app is. Is that an online app? That means you get a request and the response. Or it's a batch process. You have some documentations in the folder and the batch process, the NLP and machine learning process, and then get the result as a batch. And are you going to make a prototype to prove a concept, or you are making an MVP to demo your idea, your app, to get in investment, or you want to do a full-scale application development? And that's all the answers you need to get clear before you start your project. And even for the models, you need to be able to compare the architecture of the models as different architecture for different AI tasks. And you also need to consider the size of the model because if you are deploying a model to edge devices, and the size, the memory usage is very crucial. Also, other factors is very important should be considered for successful application, like throughput, scalability, and the securities. And the security actually is compared to conventional one, is quite unique for AI because AI sometimes it require your faces, your personal identities, and those are sensitive things involved in user privacies, and that should be put into priority. Also, the deployment, you want to put your model running on the Raspberry Pi, Jetson, or you have a centralized server. All these things, once you get clear, and then you can start your development. I'm going to use a demo app to illustrate all the concepts and ideas here. Here, I'm going to reproduce the magic eraser Google have in their Pixel 6 phone, latest phone. I was impressed by the app, and I think, okay, maybe I can just do it myself just for fun. And I started my research. I came across the implant model provided by Samsung. I have the link listed in the last page, and you can check out by yourself. And I also write web client apps using Vue.js because I'm software engineer, really familiar with all these things. And for the backend, I'm using Fast API. That's a very popular among the Python developers, and they really like it. And I also write HTTP REST wrapper to the model. So here's the simple, briefly diagram to the architecture of this thing. We're going to have the app as a pure static resource. That means only JavaScript and HTML can be hosting anywhere like a CDN or web server. And then there's going to be a backend web server with the API web service running to talk to our clients. And the API service is going to receive the user input, which is binary data from a campus image, and then pre-process, that means involving normalization, resizing, and then send to our model to do the inference. The model process the input and give a result and return to the client app. So I'm going to show you the final result of this app. So can you see the page well?
Yeah.
All right, great. So I host it in our internal server. I'm going to open it. I'm going to deploy to somewhere in the cloud so everybody can access later in the future. But now I just want to demo it. Um, I can upload the image I just downloaded from the web. And see, I want to do some Photoshop. I want to remove these kids from the sand. I probably is to. Oh, at the same time, I want to show the resource we're using here. So the model is hosting a server with A100 GPU and with 40 gig of memory. I know it's a very luxury. So you see the result is pretty good. The case is gone at I can just do more touch. You see, I'm pretty happy with the result of this one, and probably flowers. Let's do a flower. Look at this. Look at this. And all these things are open source model, the code. I refer to multiple open source code base for the canvas, for the drawing. So it's kind of feasible to just use the available open source models and to make a decent product. So what that means to us as a software engineers and today's resource, we can do a lot of things that we couldn't do before. And with our skills, we can bring the latest state-of-art models to great ideas into the hands of customers and users. Before we can start the development, as Chen in previous, because nothing is just only rainbows, right? I will give you some warning. We have all the skills of JavaScript. We have the skill of backend servers, APIs, REST. Even we have the knowledge of the models, and there's still some hurdles we're going to overcome, such as the environment. My experience in my AI projects, I always fighting for the environment. You're going to be you're going to look at the version of the NVIDIA drivers, the CUDA versions, and then Your TensorFlow versions probably working in one of these combination, but not another one. And when you run a PyTorch and suddenly everything not going to work. I know you can use virtual environment, but it's still not very clean. And for CUDA drivers and NVIDIA drivers, the virtual environment not going to help you at all. So first, you understand your current environment. Using the NVIDIA SMI to have the driver versions and the CUDA versions. When you download the pre-trained models, make sure you check what the environment your model is compatible with. Because some old models is not actually comparable with the latest CUDA or driver. And that's exactly what I had with the in-painting model I was using in the demo. So that requires Docker. I strongly suggest you have all the environment containerized, have all your dependencies in the container. So another thing is, once you have your app deployed, and there's still some steps you're going to pay attention to. If you are making a prototype, that's fine. But if you're doing even MVP, even you do a production level things, it's beyond DevOps. You have a concept of MLOps. The thing is, MLOps is an extension to DevOps. We have some unique challenges, such as the model. The model usually huge. The newer model, the more likely it's bigger. The in-paint model I was using is 2 gig, and then the checkpoint is multiple gig as well. How you host your models, where you put them, and how you versioning them, how you evolving, because in the latest NGN's MLOps, the concept of domain drift, the data drift, all leading you the iteration of your models beside the iteration of the application development. So that's some topic I'm going to follow in the future and have some more in-depth discussion, as well as logging. You have to collecting all the user logs and application logs, system logs for you to do debugging, to do analysis, also monitoring. Most AI applications intensively rely on GPU, and the GPU resource is limited and it's expensive. Most process actually, the AI process are going to take a much longer time than just the traditional HTTP request, probably in 15 milliseconds. A process like a process the image and do the inpainting or something like a deep fake swap a partial of the things is going to probably count in seconds. You have to monitor your resource usage. You're probably going to have drop queues, message queues to inline the process. All the things is beyond today's scope, but we're going to talk in the future. Hopefully, this can be useful when you start doing your great app, and you rely on this thing as a reference. And I have the source code available into our GitHub. I probably ran out of time to show the code itself, but you can check it out yourself. Once you understand the different part, and it should be very straightforward to look in the source code because I structure the source code like this way. And we also have the Docker image. You want to skip all the hassle, so you can always, the first thing is you have to make A driver version 460 op and the CUDA 10.2 op. Yep, pay attention to that. And you can forward the Docker image and run locally. You have to use the NVIDIA Docker tool to enable GPU, otherwise you're going to see error message. There's some kind of a reference I listed here, and you can check out here. And the model is hosted in this GitHub, and there are fast API, Hugging Face, and those code model repositories. And you can check that out by yourself. And if you have any questions, feel free to contact me. I'm going to leave my, they're probably just typing my here, ERD.
Yeah, leave your email address. Sorry for my.
Yeah, feel
Sorry.
free to send me email questions, and we can have discussions. And probably, if you have some great idea, we can make it an app together. Or yeah, all welcome.
Okay.
So, any questions so far?